Hello there. In lesson 113, operations with functions, you're going to learn how to add, subtract, multiply, and divide two functions together. And also, you'll learn how to determine the domain of those new functions, especially the last one. So let's start by first reviewing how to get the domain of a function. Remember, the domain of a function is the largest set of real numbers for which the value of f of x, again, is going to be a real number. So the y, you plug in a number, you get a real number out. Now, you exclude it from the function's domain are any real numbers, any values of x that is going to result in dividing by 0. In other words, any values of x that result in which f of x is undefinable, okay? That we do not get a value for the y, the output value. So let's look at some examples of this. Now, in this example, there is no way that we divide by 0. There is no value of x that gives me an undefinable term. Even the number 0, if I use 0, f of 0 simply multiplies the 7 with 0 and multiplies 0 by itself and then subtracts a bunch of zeros. So I do get an output value out of this. And because there is no possible number for x that will give me something that is undefinable, that's undefined, that means that the domain for these type of functions is going to be all real numbers. Now, the type of functions that start excluding values are these functions where our x value is in the denominator. This is how we end up with the possibility of having something that's undefined, having a denominator or having a value that ends up having us divide by 0. And the way we find that number is by getting our denominator of 2x minus 5 and setting that equal to 0. So adding 5 to both sides and solving this equation, we start by adding 5 to both sides, dividing by 2. We get that x equals to 5 over 2. So look what happens when I plug in 5 over 2 into this function. So I have 3 in my numerator. I have 2 times 5 over 2. I'm replacing the x with 5 over 2 minus 5. And 2 times 5 over 2, that's going to equal to 5. And 5 minus 5 is 0. So look what happens. When I plug in 5 over 2, I end up with 3 divided by 0, which again is undefined. I cannot define the value of 3 divided by 0. So because of this, that means that this number is excluded from the domain. So 5 over 2 is not allowed and cannot be used as a substitution for x because we get something that is undefined. So the domain for this function excludes 5 over 2. So x cannot equal to 5 over 2, which on a number line looks like this. I'm just going to put 5 over 2 in the middle. I know it's not really in the center, 0's in the center, but we have an open circle at 5 over 2, and we're jumping on our x number line all of the values of x. So x could equal to anything except for 5 over 2. And that's what this looks like visually as a graph, as a number line. As an interval, which is how I expect you to write today's domain, my answer will be written like this. So this is how we indicate that x is not equal to 5 over 2 as an interval. So let's look at another example. So let's see. Find me again the value of x. So pause the video and find what the value of x will make this function undefined. All right, so let's check your work. So to do that, we get our denominator, set this equal to 0, and solve for x. So we'll start by subtracting 7 on both sides. We divide by 2, and x equals to negative 7 divided by 2. So let's check. So let's substitute in negative 7 over 2 into the x. So let's have 3 times negative 7 over 2 and 2 times negative 7 over 2. So 3 times negative 7 over 2 that equals to 8.5. No, 9.5. Negative 9.5 on the top. I stand corrected. That's 10.5. And on the bottom, multiplying 2 with this number is going to give us negative 7. And then subtracting the two sevens, negative 7 plus 7, that's equal to 0, which again is undefined. So you see, this again is undefined. So I can use any number for x except for that number. So I cannot have x equal to negative 7 over 2, because when I do that substitution, this function is now undefined at that value of x. So our domain will be everything except for that number. And as a number line, that looks like this. Oops. And as an interval, how I expect you to write your answer, this is what that looks like. So it looks like that. Let's see, do one more. Try this last example. Let's check your work. So let's see. Let's have x squared minus 9 equal to 0. So we'll add 9 to both sides. We'll take the square roots. So x will equal to positive and negative 3. So let's start with positive 3. If I plug in positive 3, this would be 5 times 3 plus 9 over 3 to the second power minus 9, which is, that's 24 on the top and 0 on the bottom. So this again is undefined. 3 to the second power is 9, and 9 minus 9 is 0. So again, undefined. So we cannot have x equal to positive 3. Now let's plug in negative 3. If I plug in negative 3, I end up with 5 times negative 3 plus 9 over negative 3 to the second power minus 9. Which in the numerator I get negative 6, but in the denominator again I end up with 0, because negative 3 to the second power is also positive 9, and 9 minus 9 is 0. So you see, again, I get that my function is undefined when I plug in either positive or negative 3. So I cannot have x also neither equal to negative 3. So as a number line, as a horizontal number line, that would mean we have an open circle above negative 3 and an open circle above positive 3. So we can pick all of the numbers to the right of negative 3, positive 3, all the numbers to the left of negative 3, and then all the numbers in between negative and positive 3. And as an interval, that looks like this. So that's our domain. Now, we're going to apply this rule again when we look at the division of two functions. So let's go over again the operators of functions. So our four operations are addition, subtraction, multiplication, and division. And this is again the notation that we indicate. Now, this x right here doesn't mean that we're multiplying again both of these things by some number x. F is the name of the function and g is the name of another second function, and we want to add them, subtract, multiply them, or divide them. So the equivalent notation of f plus g of x is f of x plus g of x. Similarly, the notation of f minus g of x is f of x minus g of x. And then we have f of x times g of x and f of x over g of x, such as long that g of x does not equal to 0. Again, which again correlates to what we were just discussing in the prior examples about our domain not, again, excluding any possibility of dividing by 0 in these type of functions here. So let's look at some examples of adding, subtracting, multiplying, and dividing. So here we have the function f, we have the function g, and we want to start by adding these two things together. Well, again, this notation means to get f of x and simply add it with g of x. So f of x, g of x, and we want to add them together. So doing the substitution for f, which is 2x to the second power minus 3, and doing the substitution for g, which is x minus 4, I'm simply going to add those two things together. And because I'm adding, I don't have to group them with using parentheses, as you'll see that I do with the other ones. I can just simply write my two functions and simplify this by combining like terms. So this is my answer. This is what f plus g in terms of x equals. X squared plus x minus 7. And again, minus 7 because I combined these two terms. So negative 3 minus 4 equals negative 7. So I subtract 7 at the end. And again, the order doesn't matter. I put them in this order here, but if you wrote them in a different order, like this, that's going to also be correct. Let's go now to subtraction. Also, subtracting means again that we're simply going to replace f with 2x squared minus 3, g with x minus 4, and now we're going to subtract the two functions. Now, because I'm subtracting, the g function is going to be really important that this time around I put parentheses around x minus 4. I put parentheses around my g. That way I subtract not just only the first term, but all of the terms for g. So I need to subtract every single one of these, which is done easier by putting that parentheses and distributing the negative sign to that second function. So that changes the x to a negative and the 4 to a positive, and now combining the two like terms, which again are the negative 4 and the negative 3, and the positive 4, we end up with this. So this is f minus g of x. To multiply functions, I'm going to organize this using geometry. So I have, again, f of x, which is the 2x to the second power minus 3. And I'm going to multiply that with x minus 4. So here, I'm simply going to multiply these two things first by x, which is 2x to the third power minus 3x. And then I multiply these two things by negative 4. So negative 8x squared plus 12. And I like organizing my work like this instead, because if there are any like terms, they're usually diagonal of each other. And in this case, these are not like terms, so I don't have to combine them. These are not like terms, so I do not have to combine those either. So my answer is going to equal to 2x to the third minus 8x to the second minus 3x plus 12. And again, you could arrange them in any order that you want, but that's going to be your answer. And I've overlooked this. I haven't determined the domain for any of them, but the domain for all of these so far is all real numbers. These do not have any restriction because I'm not dividing again. There's no possibility of having this be undefined, since there's no way of plugging in an x that will end up dividing by 0. So all real numbers. And the same thing here. Is also going to be all real numbers. And the domain for f g of x is also going to be right now all real numbers. So these examples have all real numbers for their domain. Now as soon as I get to this one, that's going to change, because here I want to get f of x and put it over g of x. And this is the easiest one to do, because I'm not going to ask you to actually divide things out, and I just simply want you to write it as a ratio of one thing over the other. So 2x squared minus 3 over x minus 4. Now, for the domain of this thing, I have to look at my denominator and exclude any number of x that will make x minus 4 equal to 0. So here, by adding 4 to both sides, I find that x equals to positive 4. So that's the number I'm going to exclude for the domain of f over g of x. X cannot equal to positive 4. Now, how I want you to write your answer is going to be in interval notation. So since x cannot equal to positive 4, we're going to jump over 4. So from negative infinity to positive infinity, we're going to jump over 4 and omit the number 4, which is how we write this in interval notation. Let's see. Pause the video and check your work for this one. Add these two functions together. Let's see, let's check your work. So here we're going to add f and g. So f is x plus 8. G is x squared minus 4. And because we're adding them, like I said, we don't need parentheses. And all we need to do is combine like terms. So x squared plus x plus 4 is your answer. And the domain is all real numbers. There's no restrictions on this, no possibility of dividing by 0, no matter what number of x I plug in, and my domain will be all real numbers. Let's see now, pause the video for the second example and subtract the same two functions. So let's check your work. So here we'll have x plus 8, but because I want to subtract g, I'm going to put g in parentheses. So this would be x plus 8. Distribute that negative sign to both terms of g. That's a negative x squared and a positive 4. We end up with x minus x squared, then plus 12. Or any combination, any order of this. 12 minus x squared plus x, negative x squared plus x plus 12. Again, you get the idea. And again, because this one has no restrictions, the domain is all real numbers. Now for number 7, we're multiplying f and g. So f is x plus 8 and g is x squared minus 4. Here, I put parentheses around both of them because, again, I want to multiply all of this with all of g. And instead of using distribution, again, I like my geometry approach to this. And I create a 2 by 2 box, since there's 2 terms for f and 2 terms for g. I multiply first these two things by x squared. So I'll be x to the third plus 8x to the second power. And then I multiply these two things by negative 4. So negative 4x and negative 32. Again, there are no like terms. So our answer is 8x to the third power plus 8x to the second minus 4x minus 32. And again, these do not have any restrictions, so the domain, again, all real numbers. This one simply puts f over g, and there's your answer. But to find the domain, to figure out what numbers we have to exclude, on this one there has to be some exclusion because there's a possibility of dividing by 0, plugging in a number for x that will make x minus 4 equal to 0. X squared minus 4 equal to 0. We have to find out what those values are. So here, we'll add 4 to both sides. Take the square roots to both of these sides. So x equals to the square root of 4. And we get that the square root of 4 is 2. So we get positive and negative 2. So the domain here is going to exclude, again, those two values. So x cannot equal a positive nor negative 2 because then we end up dividing by 0. And this is what our domain is. So we'll do all the numbers less than negative 2. So from negative infinity to negative 2. All the numbers greater than positive 2. So from 2 to positive infinity. And all the numbers in between negative and positive 2. So that's that middle part there. All right, let's look at the last two problems. So now in the last two problems, numbers 9 and number 10 here, we want to evaluate the combined function. So here I want to add f and g together and then plug in the value of x. So I can do that in that order, okay? Or the other thing I can do is that recall that this notation means that I have f of 5 instead of x, it's f of 5 plus g of 5. So I can plug in the 5 into the x function, the 5 into the g function, f function, and the 5 into the g function, and figure out what those values are. And then add them together after I know what those values are. So if I plug in 5 into this is 5 plus 8, which is a total of 13. And if I plug in the 5 into the g, that'll be 5 to the second power, which is 25 minus 4, which is 21. So adding 13 plus 21 is a total of 24. So I get my answer. That's what this expression means. Now I can also do it this other way, because I already know from example number 5 that adding these two, let me go back to it, that adding f and g is equal to x squared plus x plus 4. So getting this f plus g of 5 simply means that I replace the 5 into the sum of these two things. So I can also do it that way. Add the two functions together and then plug in 5. Which again is 25 plus 5 plus 4. Hold on, did I write that right? I think I might have forgotten something. No, that's correct. Eight, 9, 10, 11, 12, 13. Oh, 34. Duh. And like, it's not adding up correctly because I added this wrong. 34, my bad. So that should be 34. And now that makes more sense because when I add 25 with 5 and 4, that also equals 34. So you see, I get the same answer either way. I find it easier to do it this first method first, to plug in, since we're looking for the sum of f plus g when x is equal to 5, to first plug in the 5 into the x for both functions, and then in this situation add the two functions together. So like on number 10, again, we could do it both ways, but like I said, I prefer plugging in my x value, and then in this situation I would then multiply those two things. So here, if I plug in the 2 into the x, that's going to give us a positive 6. If I plug in a 2 into this one, that is equal to 0, because this is going to be 4, and 4 minus 4 is 0. Negative 2 to the second power is positive 4. So 4 minus 4 is 0. And multiplying 6 times 0 is, again, 0. And look how much convenient this is compared to first multiplying the two functions, which again we already did in example number 7. Okay, which is x to the third power plus 8x to the second minus 4x minus 32, and then plugging in negative 2. We end up with negative 8, negative 16, positive 8. Oh, my bad, that's a square. So that's going to be positive 32, positive 8, and negative 32. That again is equal to 0. That's also going to equal to 0. And again, but like I said, look how more convenient it is to first plug it in and then do the operation, rather than do the operation, get to this new function, and then plugging in the value. But again, it's up to you to decide what you rather do. All right. Well, that concludes again our examples for these notes for this lesson. If you do have any questions, please send me a message or in mind or an email. And again, I appreciate you watching, and I hope you have a great day.